Okay, so part 2 of today's video is looking at how we draw covalent bonds. Now it is similar in some aspects to ionic bonding. We need to look at the electrons, how many electrons are in the outer shell, and how many we need for a full outer shell. But actually how we draw them, and you might have seen this when you've looked at them in your books from last lesson, is different to ionic bonding. So the molecules look different to how our ionic substances look. So we're going to do a few examples today. I'm going to look at 4 different examples to show you the different types that you might come across in your exams. So to start us off, we are going to look at the bonding in hydrogen gas. So the formula for hydrogen gas is H2. And if I wanted to draw sort of a simple diagram to represent the covalent bonds in hydrogen, I would use the stick model, which you looked at last lesson, and this is the displayed formula. Now hydrogen is nice and easy because it's just one hydrogen atom bonded to another hydrogen atom like that. So that's the stick formula, and you might remember this kind of formula up on my wall on the naming compounds section in the lab. Now this line here represents the covalent bond between the 2 hydrogen atoms, and can you remember from last video I said that a covalent bond is a shared pair of electrons, and this line here represents that shared pair of electrons. Now there is another way of representing this, and that is using the dot and cross diagram, which is slightly more complicated, but there is a method to how we draw the actually draw the atoms in there. So first of all, what we want to do is look at hydrogen in the periodic table, because we need to work out numbers of electrons and things like that. So if I can hold this steady, we've got hydrogen here. So we know, because the bottom number is 1, that hydrogen has 1 electron in its outer shell. So one atom of hydrogen would look like that. Because hydrogen has got 1 electron and it's just got this very first shell, we know that hydrogen wants 1 more electron to have a full outer shell. Because in this one, because it's the first outer shell, hydrogen needs to get 2 electrons to have a full outer shell. Obviously with our bigger atoms, we're then looking at having 8 electrons to have a full outer shell. Now fortunately we've got 2 atoms of hydrogen, both that have 1 electron in their outer shell, and we know that they both want 1 to have a full outer shell. So when you're drawing covalent bonds, what you need to do is look at how many electrons does the atom need to gain a full outer shell. And this will tell you how many electrons it needs then to fill that shell, and how many covalent bonds it's actually going to form. So we know that both of these hydrogen atoms need 1 extra electron, so they're going to form 1 covalent bond. I'll show you how we draw that now. So let me just get rid of this. So we know that the structure looks like this. So hydrogen bonded to hydrogen. So our atoms are joined. Now when we draw them, we're now drawing the electron levels, the shells, but because they're sharing electrons, we have a bit where it is overlapped here. So that's how I'm going to start out by drawing my structure for H2. So we know, as we said before, hydrogen has 1 electron, but it wants 2 to gain a full outer shell. So if I use crosses to represent this hydrogen, I know it's got 1, so I'm going to put it in this shared part here. And for this hydrogen, we'll use dots to represent it. So I know this hydrogen has got 1 electron in its outer shell, and they both want to form 1 covalent bond, which is what this section in the middle here is, where these electrons are being shared. So if I add in my dot for this hydrogen, if we now look at them individually, so my hydrogen on the left hand side here going round has got 2 electrons. So because it's the first shell, we know it's got a full outer shell. And then if we swap over, so this hydrogen here has got 2 electrons as well. So again, because it's the first shell, it's now got a full outer shell. So both of these hydrogens are now happy because they've shared this pair of electrons, which is the same as this here. So if we were to draw it on, it would look something like that. That's the shared pair of electrons. So they're both happy because they have got a full outer shell. So that's our first example, hydrogen gas. Now, sometimes they might share more than one pair of electrons, and it just depends how many covalent bonds they need to form to get a full outer shell. So this here, with the one pair of electrons being shared, is a single covalent bond. So one single covalent bond is one of these, a pair of electrons being shared, one dot and one cross, a single covalent bond. Now we can get double and we can get triple covalent bonds as well, which we will look at over the next couple of examples. So our next example that we're going to look at is oxygen, which is O2. Now before I draw any of the other molecules the way we represent it, we need to look at oxygen on the periodic table. So we find oxygen here on the periodic table, line up right. So we know oxygen has got 8 electrons overall. So if we just draw a quick sketch of an oxygen atom, we know it's got 2 in its first shell, and then we've got 6 left. So 1, 2, 3, 4, 5, 6. So we've got 6 electrons. Oh, no we don't. 6 electrons, there we go, on its outer shell. So we've got space here for 2 more electrons. So in order for oxygen to have a full outer shell, we know it needs 2 electrons. And if it needs 2 electrons, it's going to form 2 covalent bonds. So however many electrons it needs is the number of covalent bonds that it's going to form. So this time our displayed diagram for oxygen is going to look slightly different than the hydrogen because it's going to form 2 covalent bonds and we only have 2 oxygen molecules. It must be that those 2 covalent bonds are between both of the oxygen molecules. So this time, you might have guessed, a single line was a single bond. Now we've got 2 joining the oxygens. This is an example of our double bond because I've got 2 covalent bonds joining a pair of atoms. So what we'll do is we'll look at how we draw this in terms of the electrons. So same as before, we've got 2 oxygen atoms. So in terms of our diagram, it's going to look very similar to the hydrogen. Our circles. So again, we've got this area in the middle where our electrons are being shared between the oxygen atoms. So I'll just label them oxygen so that we know what they are. But this time, rather than having one pair of shared electrons, we've got 2 covalent bonds. Don't have enough room there. Which means we're going to have 2 pairs of electrons being shared. So if I think about my oxygen atom before, we said we had 6 electrons on the outer shell, but my oxygen here is going to share 2 electrons with this oxygen. So again, if we do crosses and we do dots, so I'm going to share 2 from this oxygen. And this oxygen, again, had 6 electrons. It wants 2 more, so it's going to share 2 of its own. And we've got 2 dots. And now we need to look at filling in the rest of the shells, because at the moment they aren't complete. They've both just got 4 electrons. So I said this oxygen's got 6 electrons. I've already got 1, 2 here. So I'm going to add in the others. 3, 4, 5, 6. So it's got its 6 electrons that it had originally. And this oxygen, same again. So we've got 1, 2, 3, 4, 5, 6, like that. And if we look at them individually, so if I cover up this oxygen, we've got 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has got 8 electrons in its outer shell. Perfect, it's full. And 1, 2, 3, 4, 5, 6, 7, 8 for this oxygen. So they've both got 8 electrons now in their outer shell just by sharing these 2 pairs of electrons in the middle. Now, often a mistake people make when they're drawing these is they get a bit carried away with themselves with how many electrons they add in, because we're used to having our electrons the top, the right, the middle and the bottom in our circles. We just pop a pair in each of those. However, if I was to do that this time, so let's say I filled in all the gaps, I've actually, this oxygen has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, and we know that they can't go above 8. So just make sure when you're drawing them that you don't get too happy putting electrons in, and always count them individually at the end to make sure you haven't got more than 8 or you haven't got less than 8, because it's always going to have 8 in its outer shell once it's formed a covalent bond, or 2 if it's a smaller one. So if it's hydrogen, it's just going to have 2 to have its full outer shell. So we've got 2 more examples that we are going to look at. So the next one is nitrogen gas. So we've done H2, O2, and now we're going to look at N2. So again, first thing we need to do is find nitrogen on the periodic table. So nitrogen is there on the periodic table. So we can see that nitrogen has got 7 electrons and it's in group 5. So we know it's got 5 electrons in its outer shell. So we just do a quick sketch of a nitrogen atom. So 1, 2, and then 3, 4, 5, 6, 7. So my nitrogen atom has got space for 3 more electrons. It needs 3 electrons, therefore it's going to form 3 covalent bonds. So a bit like hydrogen needed 1, so it formed 1 covalent bond. Oxygen needed 2, so it formed 2 covalent bonds. Nitrogen needs 3, so it's going to form 3 covalent bonds. And looking at our displayed formula, so the ones with the sticks, we've only got 2 nitrogen atoms, so it's going to have to form those 3 covalent bonds between the 2 nitrogen atoms. And if you hadn't guessed, like before, so we had double and single bonds, because we've got 3, this one is a triple covalent bond. Now you'd be pleased to know we don't go above triple covalent bonds in chemistry, so it's either 1, 2 or 3, but we don't go any higher than that. So now we'll go to draw our diagram with the electrons, and again, because we've just got 2 nitrogen atoms, it's going to have to look like this. So 2 nitrogen atoms with the section in the middle, which you can see I'm drawing quite big on this one, to share the electrons. So what I need to remember is that nitrogen has 5 electrons in its outer shell. So I need to have each nitrogen atom having its own 5 electrons, but overall we want it to have 8 electrons in its full outer shell. So we've said we've got a triple bond. So this nitrogen is going to have 3 electrons in the middle, 1 for each triple bond. And this nitrogen again is going to do the same. It's going to have 3 electrons in the middle, 1 for each bond, like that. So we've got an awful lot of electrons now here in the middle. So we know that each nitrogen has 5 of its own electrons. So we need to just add them up. So at the moment, if we have this nitrogen as crosses, it's got 1, 2, 3. So I've got 2 more to go for 5. And same for this one, 1, 2, 3. 2 more to go for 5, like that. And now we want to double check that we have got enough electrons overall. So if I cover up this nitrogen, I've got 1, 2, 3, 4, 5, 6, 7, 8. Perfect. It's got 8 electrons. It's got a full outer shell. And then on this one, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 electrons on this nitrogen. So they've both got full outer shells. Now the way this relates to this diagram, so if I just draw it a little bit bigger, so we've got these 3 bonds. Each of those bonds is representing a dot and a cross like this. Just got to draw them slightly skewish so they fit in. So that's what each of those lines represent. Now I'm just going to do one more example before I let you crack on with drawing these in your books. This example is slightly different because rather than just having two of the same atom, it's got different atoms in there. So the example that we're going to look at is water, which is H2O, as we know. Now we've already looked at hydrogen and oxygen in the previous examples, so we know how many electrons they've got and how many they need. So just as a quick reminder, hydrogen has got 1 in its outer shell and it wants 1 more. Oxygen has got 6, 1, 2, 3, 4, 5, 6 in its outer shell and it wants 2. So can we see how this links up to the formula? Oxygen wants 2 more electrons and we've got 2 hydrogens in the formula. So what that means is each hydrogen is going to be sharing one of its electrons with oxygen so that it can form properly. And oxygen is going to be sharing 2 of its electrons with each hydrogen, again, so that they can have a full outer shell. Now this time the structure is slightly different and these are the ones that you're going to have to learn where the atoms go. You probably recognise some of them, but for this structure we've got oxygen in the middle like this, and then we've got 2 hydrogen atoms attached like that. And that's often where we see the shape of the structure coming from with water, like that. So HOH is how we see the structure usually. Now remember what we said before, we look at how many electrons it needs and that's how many covalent bonds it's going to form. So hydrogen needs 1 electron, so it's going to form 1 covalent bond. So it's going to pop its electron there, and same for this hydrogen, it needs 1 electron, so it's going to form 1 covalent bond. Oxygen needs 2 electrons, so it's going to form 2 covalent bonds, 1 with each of these hydrogens. So if I put a dot there to represent 1 electron and a dot there to represent the other, we've now got 2 covalent bonds, and actually our hydrogens are happy because they've both got full outer shells of electrons, but our oxygen isn't happy just yet. We haven't quite got enough electrons. So we said oxygen's got 6 electrons in its outer shell. We need to make sure oxygen has its own 6. So if we say the oxygen is dots, we've got 1, 2, 3, 4, 5, 6 electrons like that. And now if we have a look at our oxygen overall, it's got 1, 2, 3, 4, 5, 6, 7, 8. So oxygen's happy, it's got a full outer shell, and hydrogen is happy, it's also got its full outer shell, the 2 different hydrogen atoms there. So that's it for drawing covalent bonds. We will practice doing these quite a lot, and as I said, there are 7 that you need to know how to draw that are in your revision guide, and we will practice drawing them. Okay.